Okay, welcome back everybody. In this last video, we're going to look at another exponential function that has a lot of applications. This Newton's law of cooling. It can be a little confusing, and it comes in different forms sometimes, and I'll tell you what. This d sub 0 is if d sub 0 is the initial temperature difference between an object and its surroundings, have temperature T sub s. Okay, so d sub 0 is the difference between the object and its surroundings, and T sub s is the surrounding temperature, okay? And I guess that little subscript there lets me know that is the surrounding temperature. Then the temperature of the object at time t is modeled by the function, and it gives me this exponential function below. Okay, where k is a positive constant that depends on the type of object. All right, so you're going to probably, with these problems, need to solve for a k before you can do anything, unless they give it to you. If they do, then they give you an easy problem probably. The one I have down here, and we'll be careful and set this up. We'll take our time on it here. It says a cup of coffee has a temperature of 200. All right, and it's placed in a room that has a temperature of 70. That 70 is your T sub s, right? And the difference between the two, d sub 0, is 200 minus 70. So that's how you find those. And it says after 10 minutes, the temperature of the coffee is 150. Find the temperature of the coffee after 15 minutes. Okay, so let's plug in what we know here and kind of get started on this thing. Let's see. All right, so right out of the gate, what do we know? Let's set up as much of this equation as we possibly can. T of t. Oops, not cap t. My caps are locked. T of t equals. All right, for the text we know T sub s is 70. So we'll say 70 plus. All right, from the text we know d sub 0 is 200 minus 70. So we're going to call that 130. Now we know we have e raised to the negative, don't know the constant, kt, right? And that's what we know so far. That's not a bad start. And if we start reading into this, we can see an opportunity to solve for k here, because they're giving me the temperature, which is T of t. It was 150 after 10 minutes. So I can plug that 10 in from a t there and solve for this k. And that's what we're going to have to do. So our next line would be something like this. We'd have 150 equals 70. I'm going to do some cheating for a second. It's funny, every time I say that I try it and it really just slows me down. Have y'all noticed that? Okay, so this is going to be the negative 10k, right? Because they're telling me the time is 10. We're going to put negative 10k. Let's make sure that makes sense. None of that changed, but up here we are told the time is 10, so I just rearranged the order there and commutativity, and we get this. So let's see if we can simplify this. And we'll come over here and write it again. All right, so it looks like we could subtract 70 from both sides, which would give me 80 equals 130. Well, let's write it. 80 equals 130. And again, I should be copying and pasting to speed things up a little bit here. We'll just take that and go in here and paste it. All right, now when we divide by 130 on both sides, because again we want to isolate our exponential expression, we're going to get 8/13. All right, so we're going to insert another equation, and we're going to have 8/13 equals e to the negative 10k. Right? Okay, at this point you need to take the natural log of both sides. Remember, all we're doing in this process here is solving for k. And I know it's a little bit involved, it takes a little bit of time, but the next question will be easy once we get this done. So we're going to solve for k by taking the natural log of both sides. And that will be natural log of 8/13. Gotta love all these fractions. I'd be better off in these videos to use decimals so I don't have all this. I'll have my pad back in the next videos though. Equals. Oh, don't want to do that. Come outside. Equals. Oh, what did I just do? Yeah, that's aggravating. I think I'm just going to have to retype the thing. I know what's wrong. I'm using that template and I'm trying to undo the whole template. That's what it is. And now we need to say equals. Okay, when you take the natural log with it, e here, it gives you the exponent. Okay, so I don't want to have to retype that as slow as I already am. Okay. All right, so now we know the last step here is to divide by -10. So that would be, our next statement will be k equals. And let's put that in here. And we'll know what k is now. So k equals, not insert, oh, give me that fraction. There we go. I want the natural log of 13, natural log, and here we go with this fun thing again. Let's see how much work I have to do to make stuff. 8/13. I know there's better editors out there. Divided by -10. And what is this going to be approximately? And we got to find out, don't we? So let's see. What do we get? Let's go to our handy dandy calculator. Figure that out, and I'm going to get the natural log of 8/13 divided by -10. And the negative is important, so don't just throw that out like it's no big deal. Okay, so we'll type that in, and it's approximately what, .04855, say. Okay. And finally, we're going to answer their question. Find the temperature of the coffee after 15 minutes. So basically, what we can do now is take this guy and fill in the last of our, let's start a new page down here. So we've got that, but now we can come in here and edit K. We know K. K is now 0.04885. All right, so now we have a complete equation. We know our constant. And finally, their last answer to answer their final question is they want to know what is T of 15, right? And that means we just replace our T with 15. And that, like I said, we did all the work up front. Remember, this is a function of minutes. And that is going to be approximately, get my favorite little symbol back out here. Let's go to the calculator. We're ready to go with that because we've already saved our rate right here. So we want 70, we're plugging it into the function, plus 130. And so, and I'm going to get my E from here. Now I want to take this thing, now we want negative KT, so I want this to be negative. I'm going to come up here and grab that value, and that's going to put it in there for me. And I'm going to say multiply that by 15. And let's see what we get. So it looks like it'd be about 132.8 degrees or something like that. Whatever they're asking for with accuracy. 132.8. All right, that should be helpful for you to get through that Delta Math. And I will see you guys in the next set of videos as a whole new unit. we're going to be working on getting this stuff wrapped up, and I'll be zooming with you. So I hope this is helpful.